following answer choices is an example of a within stimulus prompt if you are trying to get your client to identify a picture of a shovel. So when we're prompting, we have different ways to do it. We can act on the response or we can act on the stimulus. So we have response prompts or we have stimulus prompts. Response prompts would be things like modeling, where we're trying to evoke a certain response. Stimulus prompts would be things like positional prompts, where we're actually moving the stimulus around. If we're talking about a within stimulus prompt, though, what are we talking about? Well, we're talking about modifying the stimulus itself, not the position. We're not gesturing to it. We're not pointing to it. We're not physically prompting the client. We are modifying the physical aspect of the stimulus we're using. In this case, we're using a picture of a shovel. So if we're going to modify the physical aspect of that picture of a shovel, what can we do? Well, we can make it larger, right? We can change the color. It's a within that stimulus prompt. Now, we've got our information. We have our prediction. Let's see if our prediction is right. A, you move the picture of the shovel closer to the client when running a trial. It is a positional prompt, right? But it's not a within stimulus prompt. We're not changing the aspects of the prompt itself. We're just changing to the position. So we're not executing a within stimulus prompt. A is not correct. B, you point to the picture of a shovel. Okay. And this one, we're trying to act on the response, right? This is a gestural prompt, not a within stimulus prompt. C, you increase the size of the picture of the shovel. Yes, that's what we're looking for, modifying the physical features of our prompt or our stimulus, I should say. And through that, we are providing a prompt. So increasing the size of the picture of a shovel is a within stimulus prompt. And then D, you glance at the picture of the shovel. Again, that's not acting on the actual stimulus itself. That is just a simple response prompt. C is going to be our answer. You increase the size of the picture of the shovel. You conduct training with a group of teachers at your local elementary school on proper implementation of reinforcement and punishment. If the teachers start to implement these behavior analytic procedures, they are part of which of the following? On the task list, you'll notice there are different concentrations of behaviorism, things like experimental analysis of behavior, applied behavior analysis, and practice guided by behavior analysis. You need to know the difference between all three. In this case, what is happening? Remember, we're asking ourselves, what is happening in this question? Well, we're conducting training with teachers. We are training on reinforcement and punishment, so basic behavior analytic interventions, behavior analytic principles. If those teachers take our training and start implementing with their students, what concentration are they a part of? Is this experimental analysis? Is this applied behavior analysis? Or is this practice guided by behavior analysis? Well, experimental analysis of behavior typically focuses on lab research on non-human subjects. So behavior research on things like mice would be experimental analysis of behavior. If we go to B, applied behavior analysis, now be careful, okay? Don't get these two confused. Applied behavior analysis is the act of researching our behavior principles and our behavior interventions on socially valid behaviors and human subjects, okay? So in the natural environment. However, if we're actually implementing what we've learned, things like technicians and trained teachers, that's going to be practice guided by behavior analysis. So be careful with applied behavior analysis and practice guided, okay? Applied behavior analysis is more along the lines of developing interventions through human research. Practice guided is the implementation. C is what our technicians do. And then D, none of the above is obviously not the correct answer. Our answer here is going to be C, practice guided by behavior analysis. If you were to design a negative practice procedure to be used with your client, what might that look like? All right, so questions like these are simply definition questions disguised as application questions. Because what the question is really testing you on is, do you know what a negative practice procedure is? When you think negative practice, what do you think? You should be thinking punishment. Remember, we have positive practice punishment, negative practice punishment, restitutional overcorrection. If we're going to do a negative practice punishment, what is that going to look like? What are we doing with negative practice? Well, with negative practice, we want the learner to engage in the wrong behavior or the maladaptive behavior or the incorrect response over and over again. So if we're designing a intervention using negative practice, that's what we're looking for. Something where the client or the learner is engaging in the wrong response over and over. Now that we've done our work up front, We've attacked the question. We have our prediction. Let's see if we were right. A, you would have the RBT model the incorrect response before modeling the correct response. Really has nothing to do with positive practice, right? That's simple modeling by the RBT. And we're not really focused on the RBT. We're focused on the client. So A is very wrong, okay? Just not right. B, you would have the client engage in the incorrect response repeatedly. Yes, right? If we're going to do a negative practice procedure, we're going to have the client engage in the incorrect response repeatedly. What about C? You would have the client perform the correct response repeatedly. What type of intervention is this? That would be a positive practice procedure. All right. Understand the difference between negative practice, positive practice, and restitutional overcorrection. And then D, you would have the RBT perform the incorrect response repeatedly. Again, we're not focused on the RBT. We're focused on a procedure to be used with our client. Now, if you wanted to train your RBTs using negative practice, you might have them perform incorrect responses repeatedly. But in this case, who are we focused on? We're focused on our client. We want the client to engage in the incorrect response repeatedly. While studying at the library, a group of freshmen engaged in loud conversation. You put your headphones in and attempted to focus on what you were doing. Putting your headphones in will potentially serve as what? Okay, reinforcement punishment question. What are you attempting? What is happening in the question? Well, you obviously want this loud conversation to go away so you can focus. You're trying to do what? You're trying to escape the loud conversation. Escape is typically tied with what type of reinforcement or what type of punishment. Escape is typically tied with negative reinforcement. Think about a child who is given a test and they fall out their chair and they start screaming and crying. What are they trying to do? Well, they're trying to escape the exam. And if they're successful in escaping the exam, they'll be negatively reinforced, right? The demand is removed, their behavior increases. Same idea here. You're at the library, loud conversation. In response, you put your headphones in. As a consequence, loud conversation goes away. It's removed, it's negative. If your behavior increases in the future, if you continue putting your headphones in the future, your behavior has been increased and it's been reinforced. Putting your headphones in will potentially serve as negative reinforcement. Don't miss reinforcement and punishment questions on the exam. Should be very easy question, very easy points. Okay, we want to be breaking these things down. A bad habit to get into is to take easy principles like reinforcement, punishment, and extinction, and while you're studying, okay, try to move through them too quickly. The exam is still going to test you on the quote unquote easy stuff. Okay. Don't move through things quickly, right? Make sure you're getting these things correct. Do all the work while you're studying. Break everything down. Think about why the wrong answers are wrong, why the right answers are right while you're studying. So when you get to the exam, okay, it becomes that much easier, right? Again, speed, everybody wants to go fast, but speed doesn't come with trying to be fast. Speed comes with being good at the test, being fluent, and being prepared. You're talking with your RBT and you tell them you want to collect baseline data. The client's parents asks you what baseline data means. How would you explain it to them? What is happening in this question? What is this question about? This question is wanting you to do what? It's wanting you to explain something to stakeholders. And what is our rule when we explain things to stakeholders? We want to use non-technical language and we want to avoid jargon. We want to explain things to them in a way they will understand. 99% of the people you work with aren't going to understand applied behavior analysis terminology and not even things like baseline. Okay. So when we talk to them, we need to be really good at explaining our terminology in simple terms. So how are you going to explain baseline to them? A, tell them not to worry about it. It isn't important for them to know. Well, that's not the right answer, right? We work as a team, we collaborate, and the stakeholder or the parent who is interested in the intervention definitely has a right to know what baseline data means. Okay. We want to be training all the time. B, baseline data is data we take before the intervention begins. Once the baseline data is steady, we will begin our treatment. All right. This is okay. It's still a little jargony though, right? Intervention, baseline data is steady. They're not going to know what steady means. You're going to have to explain to them what steady means before we begin our treatment. Why are you doing this before we begin our treatment? Okay. It's not really telling them why we're taking this data, right? it doesn't really matter to them when the baseline is steady, we'll begin our treatment. That's for us to know. Okay, so I think we can do better than this. What about C? Baseline data is data we collect before we teach anything. It will let us know where we are starting once we do start teaching. That is much better than B. Simple terms. Okay, so they're taking data, they haven't taught anything. They want to know what can the client do right now. And then once they start teaching, they'll know where to start. C is much better than D. It actually explains why we are taking baseline data, okay, and not unnecessary things like telling them the baseline is steady. And then D, baseline data lets us know if our teaching is working. That's just incorrect, okay? Baseline data happens before teaching. Our answer here is going to be C. Baseline data is data we collect before we teach anything. It will let us know where we are starting once we do start teaching. Sue takes her daughter to the seafood market. There are fish, crab, crawfish, shrimp, and other seafoods available, but Sue's daughter just points at everything and says fish. Sue's daughter is demonstrating what? What is happening in the question? We're going to keep asking ourselves that. Sue's daughter at the seafood market, she's pointing at all the different types of seafood and saying the same word, fish. How many responses is Sue's daughter engaging in? Well, just one, the word fish. She is generalizing, right? She's generalizing fish, but fish to crab, crawfish, shrimp, and other seafoods. Now, first thing that comes to my mind is overgeneralization. But if we look at our answer choices, overgeneralization is not an option, right? Lack of generalization C is definitely not it. It isn't a response class because it's a single response, right? So it leaves us with response generalization and stimulus generalization. Well, what's our rule with response and stimulus generalization? Well, we ask ourselves, how many responses? Well, we have one response. So if we look at response generalization, that's multiple responses for one stimulus. But stimulus generalization is a single response for multiple stimuli. Which one do we have? Well, of course, we have a single response for multiple stimuli. Fish for crab, crawfish, shrimp, fish. Sue is demonstrating stimulus generalization. That's how easy generalization questions can be, okay? The basics get easier and easier the more you prepare, but you have to do your work up front, right? We have to understand what the question is asking, what is going on in the question, before we can really attack the answer choices. When behavior is influenced by a prior condition, this is considered a what? All right, so this is, again, basically a definition question, right? When we have different conditions, okay, let's say we have a condition during lunch and a condition right after lunch, right? Those are different conditions. And let's say another condition, the lead experimenter sets a bad tone for the whole experiment, changes conditions. That bad tone, if that carries over to another condition, okay, that's what we're talking about, right? One condition is influenced by another condition. What is that considered? And to make this simple, just know this, right? You don't just know this definition. Fluency, that's why it's key. So type 1 errors are what? Type 1 errors are false positives. Type 2 errors are what? False negatives. C, sequence effect, is what we're describing here. When behavior is influenced by a prior condition, it's considered a sequence effect. We're not worried about internal validity here. We're not worried about experimental control. Simply, the answer here is C. When selecting a replacement behavior to use during differential reinforcement, it is important that the behavior is what? Okay. What does the task list say about replacement behaviors? It says we must be using them, right, when we're using things like differential reinforcement or whenever we're reducing functional behaviors, okay? Fair pair rule. If you're going to reduce a functional behavior, you need to replace it with something else to meet that function. It's ethical to do that, okay? It's unethical to not do that. But when we're selecting replacement behaviors, what is it important that the behavior has? Is it important that the behavior is topographically similar or topographically different? Well, depending on what differential reinforcement procedure you're using, this could be true. But just in general, using differential reinforcement, the topography is not going to be the important part necessarily when choosing our replacement behavior. The first thing we're concerned with is C, is that the behavior is functionally equivalent. If I'm working on a behavior that functions as escape, it doesn't do me any good to teach a behavior that functions to get a tangible. We need functionally equivalent replacement behaviors when using differential reinforcement. And then D, incompatible with the old behavior. Well, if we're using DRI, sure, but what about DRA? It doesn't matter, right? So you have to be careful. We're just talking about differential reinforcement in a broad sense, okay? So if we were to say DRI, then D, okay, would be a better answer. But we're just talking about differential reinforcement broadly. So it's important that the behavior is functionally equivalent. The past week, you have studied every day for 2 hours, 3 hours, 1.5 hours, and 4.5 hours, respectively. What is the average duration of studying during the week? Okay, simple average question. BCBAs, we need to know how to do average. You just have to, right? Have to find rate, have to find averages. So this is just a little question to test your knowledge of averages. How are we going to find the averages? Well, we simply add up all of our data points. So 2 plus 3 plus 1.5 plus 4.5. And then we divide by total number of data points, which is 4. And what does that give us? 2 plus 3 plus 1.5 plus 4.5 divided by 4 is going to give us 2.75. Okay, that's our average. Now, are we worried about day or week? Well, if our data points are indicative of day, okay, we're worried about day. So we're worried about the average duration of studying during the week. So how often do we study, or how long do we study each day? Okay, and it's going to be 2.75 hours a day. And that's really what you need to be careful about. The average part's easy, but are we working with week or day, right? Well, all of our data points, okay, are days, so we need to stay consistent and find the average per day, right? We're not worried about the total duration during the week, okay? We're worried about the average duration per day. So our answer here is C. If you wanted to test for experimental control while using a changing criterion design, how might you go about it? Experimental control is when our IV has control over the DV. So what we're doing in the experiment is what is controlling the behavior. And if we want to test for that using a changing criterion design, how are we going to go about doing that? So remember, changing criterion design, okay, we are trying to increase or decrease behaviors in a stepwise manner, right? So if we're trying to increase the miles somebody runs, we might start at 1. Our next criterion will be 3. We've got to meet 3. Then 5, meet 5, on and on and on, right? If you're trying to decrease cigarettes, you start at 10, and then you go down to 8, and you go down to 6, okay? That's changing criterion, right? How are we going to test for experimental control with changing criterion? Would we A, withdraw treatment and see if behavior stays the same? What experimental design are we describing there? Well, a reversal or a withdrawal, right? We're not talking about reversal or withdrawals. We're talking about changing criterions. A is out. B, change the intervention in the middle of the criterion. Well, no, right? We're testing for experimental control. We want to know if our current intervention is what's controlling the behavior. We're not going to change the intervention, right? C, increase or decrease the criterion to a previous point and observe the effect on behavior. Yes, right? This is how you test for experimental control. If I'm trying to reduce cigarettes, let's say I start at 10 and then 8 and then 6. We're trying to see, okay, we're at 6. Does the client smoke 6? If I reverse it and go back to, or if I decrease it or increase it, I should say, I'm not going to say reverse, so I don't want to confuse you. But if we go back to 8, so let's say we go backwards from 6 to 8, and the client starts smoking 8 again, we have experimental control. Okay, that's how you test it using changing criterion design. And then D, you cannot test for experimental control using a changing criterion design. That's incorrect. Our answer here is going to be C, increase or decrease the criterion to a previous point.